All right, welcome to part 2 of the day 3 notes. Here's for some new formulas. So the 2 new formulas that we have, and these are the last 2 new angle formulas that we'll have in this circles unit. We call them in angles and out angles. Now that's not technically a high-tech name, but it gets the point across. So an in angle literally means it's inside the circle, and it's formed by the intersection of 2 chords. So when you look at the picture here, chords are just segments whose endpoints are on the circle. So you get that X shape going on. So the rule for this one, I'm going to try to write it so that it's in a nice, simple fashion to be able to understand, is I'm going to call this arc 1, and I'm going to call this guy arc 2. The angle that I'm talking about, the in angle, would be this one right here, right? So I can say that the in angle is equal to the average of the 2 arcs that it opens up to. So it's arc 1 plus arc 2 divided by 2. Now I said it opens to 2 arcs. If you can think back, those angles that are across from each other like that, those are called vertical angles. We know that from our proofs unit and from earlier in the year. And those 2 are equal to each other. So if X opens up to this arc and the angle across from it is also the same as X and it opens up to that arc, you're averaging those 2 arcs. That's how it works. So let's try it. I'm going to slide down. Keep in mind, pause the video at any point if you need to, so you have time to try the questions. So here's angle X. The arc that X opens up to is this 78-degree arc. So I'm going to call that arc 1. The vertical angle opens up to a 22-degree arc. I'm going to call that arc 2. And it doesn't matter which one you consider to be arc 1 and arc 2. Just make sure that you use both of them. X is our in angle. X is going to be equal to arc 1, 78, plus arc 2, 22, divided by 2. Please make sure when you calculate this, add these ones together first before you divide by 2. If you type it into the calculator just as 78 plus 22, and then divide by 2, it won't quite do it right, because what I'm telling the calculator right now is just to divide the 22 by 2. So I would strongly suggest do 78 plus 22, hit enter, get a number, then divide it by 2. So it's going to come out to be 100 over 2, or 50 degrees. Which, when you think about it, 78, 22, 50 makes sense because it's in between them. So please make sure that the number that you end up with falls between the measure of those 2 arcs. All right, you've got a second one. Think about how the setup is. X is the angle that we're looking for. That's our in angle. So the arcs it opens up to. We got 113 over here. I can consider that arc 1. And then use its vertical angle. The vertical angle opens up to 51. That would be arc 2. Let's add them together and divide by 2. So 113 plus 51 divided by 2. Again, when you type it into the calculator, add them first. That'll give me 164 divided by 2. So that angle has to be 82 degrees. Now, is it perfectly drawn to scale, these diagrams? No. So keep in mind, if it doesn't look perfect at 82, that's not intentional. I'm not trying to psych you out. Oops, there we go. Sorry. But that's what the measure should be here. All right, that's rule number 1. That's an in angle, when you have 2 chords that intersect. Rule number 2 for today is called an out angle. And why we call it an out angle is because it falls on the outside of the circle. So we keep it simple. It's just where it's located. So out angles are formed by the intersection These two segments are called secants. But they could also be tangents. So just a little note to self. But for today, two secants outside of the circle. All right, the rule in this case, the out angle. It's the angle where it forms out here. I'm going to call that my little x. So the out angle is going to be equal to the difference of the arcs divided by 2. To make sure that the answer comes out positive, I always want to make sure that the arc that's further away, or the bigger arc, goes first. And then you're going to subtract the smaller arc from it. So you can make it arc 1 and arc 2, but I'm going to be a little bit more specific and say the big arc. And then I'm going to call this one the small arc. So when you think about angle X, it opens up. Those two arcs are inside that angle. So this is the big one. That's the small one. So I'm going to write this as the big arc minus the small arc divided by 2. That is how I'm going to calculate that out angle. Again, 2 examples. Let's try it. Right here, there's my out angle. 110 is bigger than 45, so it should be pretty apparent which one is the big arc and which one's the small arc. To solve for x, simply take the bigger arc, 110, subtract the smaller arc, 45, divide by 2. I'm going to give you the same recommendation that I did on the last one. Subtract these first and then divide by 2. So on your calculator, whatever calculator you have, subtract, divide by 2. Oh my goodness, we got a decimal. That's totally fine. So 32.5 degrees is completely fine there. All right, one more practice one. If here's my out angle, and I know it's an out angle because it falls outside of the circle, and it kind of looks like a little ice cream cone again. You've got the big arc up here. We've got the small arc down here. All right, set it up. Big arc, 156, minus the small arc, 48, divide by 2 equals what? 156 minus 48 gives me a difference of 108. Divide that by 2. We get 54 degrees. All right, that's it for now. There is one more page of the notes for those of you that are able to print them off the website. There are practice questions back here. The first 3, you can see all of them fall inside the circle. Those are all examples of in angles. The last 3, they all fall outside the circle. Those are all examples of out angles. So try a few to practice. See how you're doing. Message me or Mrs. Golding or Mr. Murphy, whoever your teacher is, if you need help.